Hello learners, welcome to LOVECHEM. Let's make chemistry interesting. We will learn chemistry with a new approach. So let us begin with the oxyacid, or in some books it is mentioned oxoacid of halogens. So the first one here we have is the hypohalous acid. Here in this case the X, that is a halogen, it can be all, that is fluorine, chlorine, bromine and iodine. Next one type oxoacid is halous acid, where X is only the chlorine. After that we have the halic acid. In halic acid the X can be chlorine, bromine and iodine. And the last type we have here is the perhalic acid, in which the halogen is having the highest oxidation number and X can be chlorine, bromine and iodine respectively. So one important note, all oxyacids of halogens have tetrahedral geometry, and hybridization of all oxyacids of halogen have sp3 hybridization. So hypohalous acid, oxidation number of halogen, that is X, is +1. So certain examples of hypohalous acid, for example, hypofluorous acid, formula is HOF. Then hypochlorous acid, HOCl. Hypobromous acid, HOBr. And hypoiodous acid, HOI. So next we have halous acid. The oxidation number of halogen in this case is +3. So the examples of the halous acid formula is HXO2. The only example is chlorous acid. Here X is equal to Cl only, that is HClO2 is the formula. So next we have halic acid. Oxidation number of central halogen atom X is +5 here. Examples of halic acid having formula HXO3 are chloric acid, HClO3, bromic acid, HBrO3 and iodic acid having formula HiO3. Next we have perhalic acid. Perhalic acid is the strongest oxidizing agent among all oxyacids of halogen. It does not disproportionate, it means it cannot be further oxidized. Oxidation state of halogen is +7. The examples of perhalic acid HXO4 is perchloric acid HClO4, perbromic acid HBrO4 and periodic acid HiO4. Get ready for LOVECHEM trick. So guys, are you ready? So here we have Bahubali trick to calculate in oxyacids of halogen number of sigma bond, pi bonds, number of lone pairs and bond pairs. So the tricks are, if we have to calculate the number of sigma bond, it is equal to total number of atoms in a given oxyacid of halogen -1. For pi bonds, number of pi bond is equal to total number of atoms -3. For lone pairs, number of lone pairs is equal to total number of atoms +2. And finally, number of bond pair will be equal to number of oxygen atom in a given oxoacid. You multiply it by 2. Hence you will get the number of bond pair also. So for hypohalous acid, the formula is HOX. So in hypohalous acid, number of atom H, O and X. There are 3 atoms. So total number of atoms equal to 3. So number of sigma bond we can calculate, that is total number of atoms -1. So number of sigma bond becomes 3 minus 1 equal to 2. Similarly, number of pi bond is equal to total number of atoms -3. So here number of pi bonds will be equal to 3 minus 3. It comes out to be 0. Similarly, number of lone pairs will be 3 plus 2. That comes out to be 5 here. Hence, and for the number of bond pair, that was equal to the number of oxygen atom multiplied by 2. So here there is only one oxygen atom. So 1 multiplied by 2 equals to 2 only. For halous acid having formula HXO2, total number of atoms are 4. Number of sigma bond can be calculated by total number of atom minus 1, that is 4 minus 1 equals 3. Number of pi bonds, 4 minus 3, it comes out to be 1. Number of bond pair, there is 2 oxygen atom, so 2 multiplied by 2, it comes out to be 4. And number of lone pair will be equal to 4 plus 2 equals 6. So bond pair actually means total number of sigma as well as the pi bond. And in one double bond, there is one sigma as well as one pi bond. Halic acid having formula HXO3. So one molecule of halic acid contains 5 atoms. Number of sigma bond is 5 minus 1, it comes out to be 4. Number of pi bonds, 5 minus 3, it comes out to be 2. And number of bond pair, here there are 3 oxygen atoms, so 3 multiplied by 2, it comes out to be 6 bond pairs. And finally, the number of lone pair is 5 plus 2, it comes out to be 7. For perhalic acid having formula HXO4, so in one molecule, total number of atoms are 6. Number of sigma bond, we can calculate 6 minus 1, it comes out to be 5. Number of pi bond, 6 minus 3, it comes out to be 3. Similarly, number of bond pair, there are 4 oxygen atoms, so 4 multiplied by 2, it comes out to be 8 here. Finally, the number of lone pairs, that is 6 plus 2, it comes out to be 8 lone pairs. So students, I hope so your concept is clear. Thanks for watching LOVECHEM. Kindly like, share as well as the subscribe LOVECHEM channel. Press the bell icon to get the latest update regarding the LOVECHEM tips and tricks.